So we have h of 1, and then we have h of 3. And let's plug it into the function provided. So we have f of g of 1 minus 2. Then I have f of g of 3 minus 2. So starting from the inside, it's saying when x equals 1, what is our g value? So when x equals 1, what is our g? 2. So we have f of the 2 minus a 2. So now it's saying when x equals 2, what is our f? When x equals 2, f is 9. So that's going to give us 9 minus 2. What is 9 minus 2? 7. Okay, let's do the same process for the next one. When x equals 3, my g is 4. So f of 4 minus 2. And when x equals 4, my f is negative 1 minus 2. And that's going to give me negative 3. So let's compare. Between these two numbers, does that one really do exist? Yep. So let's go ahead and conclude it. But I do want you to write out the inequality form. We have h of 3 is less than 1, less than h of 1. And specifically, the numbers we found were negative 3 is less than 1, less than, was that 7? Some of you guys are getting in a habit of writing h of 1 first and h of 3. Depending on what you plug in, the result could be smaller, okay? So the order does matter. So let's go ahead and write our conclusion statement. On our conclusion statement, to make your life easy, there must be a value of s for that such that the following, just copy it from left to right. And what is it by, though?
IVT.
By IVT. There we go. We know there must be. Is it stating the original problem a good idea? Always. A value s for the intervals 1 less than s less than 3 such that h of s is equal to 1. If you want to abbreviate that, that's fine, but I have to see the interval, the value, and by IVT. Okay? So I must see this in some form, that in some form, and that in some form. And you can abbreviate it in between. Everyone good with that? So tables should be very easy. It's not even like algebra involved. Okay, for 19, it says algebraically determine the limit. So looking at this, the first thing that you should always do is what? Plug it in. So when I plug in the negative 3, I'm going to just assume you plugged it in. You should have gotten what? 0 over 0. And you should always do what? Do more. And typically it's factoring. So in this case, the top has to be factored, and I believe that might be the only issue, right? Okay, we need help with the factoring on the top. So let's go ahead and take our A and C. Looking at 4, 17, and 15, there's not a common value I can take out. So you multiply 4 and 15, which is 60. And 17 is our end result for the sum. What were the two numbers? I think you gave me the two numbers, Evan.
12 and 5.
12 and 5. So you keep the first term, which is 4x squared. You split the middle, 12x plus 5x, and you keep the last term, which is 15. And then you simply group them. So when I group the first set right here, what is my GCF? 4x. So I have remaining x plus 3. Good? What's our GCF? 5. So we have x plus 3, and we know we've done the right thing when they're identical. So we have the limit as x approaches a negative 3. Should we leave that limit notation until we plug it in at the very end? Yep. If not, I can take off points. 4x plus 5 and x plus 3, and the bottom x plus 3. What does eliminate?
X plus 3.
So there's a hole. Now once I eliminate, I could then plug this one into the remaining x. So when I do, I get 4 times negative 3 plus a 5. How many would that give us? Negative 7. And it does exist. The limit does exist at negative 7.